There doesn't seem to be a lot of content about refactoring on the internet, so here is my take on the Gilded rows refactoring code kata in Kotlin. The main point of this exercise is essentially to improve this code base to the point when we understand what it's doing and we can add a feature to it. As you can see, it's not a very big code base, just a couple of classes, and I will take the approach of refactoring the code to the point when it's clear what it's doing. Here we have item class, which has essentially 3 fields, name, sellIn, and quality, whatever that means. They are all mutable. There is also toString function, which we can refactor like this to be an expression function. Conveniently, I have already written regression tests, which pass, so we can commit the changes with this action commit without dialog, which just saves some time. Another class that we have called Gilded rows, and it has all this code. This is the main point of the exercise. One of the ways I like to explore the code, which doesn't always work, but it's to collapse and expand the code to see an overview of what there is. In this case, it does help because we can see it's only one function, updateQuality, which has one for loop inside. Because all of this runs in the loop, it's a good candidate to extract a function, which I will call update. This function takes one parameter, which is called I, which is an index, and it uses it on items array pretty much on every line. So that's a good candidate to extract as a parameter. IntelliJ has been clever in this case, and it removed I from the list of the parameters because it's no longer used. And because item is used on every line, in Kotlin it would be natural to convert this parameter to receiver. At this point, IntelliJ shows few warnings. One of them is that quality minus quality is always 0. That looks fair to me, assuming that's a single-threaded environment. And it also suggests to replace assignment with operator assignment. I'll go ahead and do it just to get rid of all the warnings on the screen. It passes all the tests. And we can notice that if we highlight items, we can notice that items are only used now in this function, updateQuality, so we can actually move the update function out of Gilded rows class completely. This looks like an improvement to me, so I'll commit the change. One thing I would do inside updateQuality function is to convert for to for each. And the reason is that for each is less flexible, so you cannot break or continue inside it. So if I see for each, I know there is nothing funny going on. And we don't really need to iterate over indices, we could just use items directly here. Now if we want to look at this function, we can still see that it's quite long. So I would try the approach of condensing this code a little bit. For example, joining these 2 lines. I don't think it's very controversial. Or removing this empty line. Basically trying to condense the code so it fits on the screen and it's a bit easier to skim. I think these changes are not very controversial, so I'll commit them. Still doesn't quite fit on the screen. We could go further and do something like that. For example, joining these ifs and joining these if else and so on. So now it does fit on the screen and it's easier to look at it, but I'm not sure about all these changes, so I'll undo them. If you spend some time looking at this code, you might notice that there are lots of comparisons for the name to not be equal to a string literal, which is a bit strange to do, in my opinion, and I would try inverting this and see where it takes us. So I'll invert a couple of conditions here. As soon as we do it, I think it becomes more obvious to me that there is some flow in the code of comparing the name to something and then updating the quality. So for HBRE, we increment in quality, for backstage, we're setting it to 0, and for not sulfurous items, we're doing -1. The last condition here is a bit tricky because we are comparing quality to 0 first. What we can do is that we can merge these 2 ifs, then we can flip the AND condition, which should be a safe transformation. And then we can split the if into 2, so we can later on invert this if and have name comparison at the top. IntelliJ now complains that if has an empty body, so I would add a dummy expression here, a dummy statement, quality minus equals 0, because it seems that all the branches are about modifying quality. Finally, we can convert this to when and remove braces. This code looks way more condensed, and I quite like it, so it would be good to try to apply similar transformations to the rest of the function. So going up from here, we can invert this function. Now IntelliJ complains about empty body. The other branch is updating sellIn, so out of symmetry, I'll do sellIn minus equals 0. And then IntelliJ now suggests that we can lift assignment out of if. So essentially it suggests to do this. I like this transformation because currently we modifying field of the item in both branches, so there is mutation in both branches of if-else. But as soon as we lift the assignment, if-else becomes an expression with no side effects. So that's a good thing. And out of symmetry with the comparison below, I would convert this to when. Finally, we can look at the if at the top. It's quite big. It still has name not equals comparison, so we can invert this if. It's a bit more complicated here because we have or. Luckily, IntelliJ has a refactoring called split if into two. It essentially copies this block of the code below, but has different conditions in if. The reason it's useful is that now we can see that this condition is always false, so we can replace it with false. And we can just delete this expression, really. And this condition is now always true, so we can replace it with true, and we can simplify this code by unwrapping the if. This is definitely a good change. Finally, we have a similar thing here that we want to merge two ifs, flip and split if into two. Then we can invert this condition. And once again, I'll do quality minus equals 0. Then we can convert this if-else to when, so that it's more similar to the code below. Looking at a bit of duplication, it's easy to notice that there is this statement mentioned 4 times in the code. It would make sense to call it, for example, increment quality, but we might also notice that there is a similar statement which decrements quality. So maybe being a bit more strategic, we could call it updateQuality. The problem I can see with it, there is already a function called updateQuality, and maybe that updateQuality is a bit not a proper name, because inside update we're also updating sellIn, so really this is just update, it's not updateQuality. Now I can extract this as updateQuality. I'll replace all the usages of this function. Could also format this a little bit. One thing which is also easy to notice at this point is that there is a very similar code over here, which looks like updateQuality, but it has this nested code inside. After thinking for a while, you might be able to convince yourself that it's a safe transformation to move these statements outside, and then this can be replaced with updateQuality. Since we ultimately want updateQuality to be configurable, it makes sense to extract one as a parameter, which I'll call change. And before we can start using it for quality -1, we can see that the comparison for quality is different compared to what we have inside the function. Essentially, the idea here is that we want to make sure that quality is within the range between 0 and 50, and we can use a function called sellIn to do that. So we can call this function on quality plus change, and then we don't need this condition for updateQuality. At this point, we should be able to replace updateQuality to use -1. There are a few other usages, there are a few other branches where we assign values to quality. In particular, we are setting quality to not be any different. So here we update quality 0 change. Unfortunately, it fails the test because for sulfurous, it turns out there is a special logic which states that its initial quality is 80 and it should never change, so it doesn't quite fit into this range. What we can do here is to add a condition which will just do another return. And if it's 0 change, we don't do anything. Finally, the last assignment of the quality is here, where we reset quality. And in this case, we can update it to be minus quality. That should work. So now we are only updating quality inside this function. And once again, we reduce the amount of places where we are mutating fields of the item. This is a good thing. We could reduce it even further. For example, in this condition, we can see that every branch is basically a call to update quality. So instead of calling update quality, we could move this function to the top level and have when as an expression with no side effects. There is no direct way to refactor it. What we can do, we can replace when with if, and then we get this refactoring called lift function call. IntelliJ will basically do this for us, so we now have only one call to update quality. And then we can convert the if to when, going to previous code style. It would be nice to pull off the same trick in this when above. The problem we have is that these 3 lines, they're not really an expression yet. After thinking for a bit, we might be able to realize that these 3 lines, they can be rearranged in any way, so they are independent updates. After we do this, we can see that if sellIn is less than 6, it's also less than 11, so we could refactor the code like this. And similarly, if we always are calling update quality, we could put it into else and update the values in the statements above. Then we can use the same refactoring called lift out of if and convert this to when, do the same trick on the whole when condition. And after removing braces, it looks quite condensed and quite nice. The benefit of this is that we are not modifying fields of the item or in every branch, we are only doing it at the very top, so we're pushing the mutability out. We still have 2 calls to update quality, and it would be nice to have just 1 call, or at least it would be nice to try. The problem we have is that there is a sellIn update in the middle, and it's a natural thing to try, I think, to move the sellIn to the top of the function. It won't work because we used to compare sellIn value before the update. So because we're updating sellIn before, we need to reduce the values by 1. Because we are only updating it by 1. This should pass the test. And the next step is to merge this to update quality. When conditions with update quality. One way of doing it could be to push this if condition with sellIn down to each branch. We could do it like this, by bulk modification and else condition which says 0. At this point we should need the outer if, and each of these conditions we can move one at a time to the when above. This can be simplified to this. This condition can be moved to be before when, and we don't need 0. For sulfurous, this if else is always 0 anyway, and this can also be moved to the else here. Once again, we could refactor it a bit straight away. And finally, we can delete this update quality because all branches are 0. This looks pretty good and quite simple. I think it's simple enough. The only problem I have right now is that there is a bit of asymmetry, that we update sellIn inside this function, but quality update is updated inside another function. It might be nice to try and inline update quality just to see what it looks like. Unfortunately, it cannot be done with early return, so we need to refactor it a bit. Now when it doesn't have early returns, it can be inlined. This looks a bit more symmetric because we have sellIn and quality update inside the same function. To be fair, I think this is simple enough to add a new feature, and it's good not to over-design things. However, what I don't like is that there is a lot of mutability going on in Item, and maybe that's the next thing I would try and change. The name, it can be already not mutable. and the class could be converted to data class, so that we strategically could create copies of item instead. This change passes all the tests. The other two fields, sellIn and quality, they are updated in our code, so we need to create new items instead of updates. To do that, we could extract a function called updateSellIn and reintroduce function updateQuality. As the next step, I would change the signatures to return the item. So in update, we could chain them in a fluent API style and refactor it like this. One of the ways to test if this code works might be to create a copy here and see if the code works with without the mutation. Unfortunately, it doesn't, and the reason is that we are not updating array of items in the Gilded rows class. So here we should do a map really and we will return an array which we can reassign to items. So this works with the copy function, and essentially what we want is to stop mutating the item and just return every time a new copy of the item. I would refactor this as well to an expression. Then we can do a similar thing for quality by returning a copy here. We could also convert this to expression, lift if, maybe invert if. Since it passes the test, we could convert, I think now, sellIn and quality to vals and make item essentially mutable. So it passes all the tests, and I think this is good enough.